Here at Station 9, the last station in the lab, we're going to look at how wind can also be harnessed to create mechanical work and electricity. Our first model here is a wind-powered lift, so that as the wind blows from the fan and turns the gear, you'll see that it lifts water into the cup. Now if we look closely at the model, you'll see that it doesn't have a motor anywhere in this system. No wires are involved. So this model is not creating electricity. It is doing work, pulling water from the tank and pouring it into the cup, but it is not generating any electricity. Now if we look at this model windmill, its fan blades are connected to a gear which connects to a motor that we can plug into a voltmeter, just like the one we used for the hand crank, and we can see how it generates electricity by turning on the fan. As the fan causes the blades to move, it generates electricity according to the voltmeter. Here's the voltage on setting 1 of the fan. If we increase the fan speed to setting 2, we'll notice that the windmill turns faster and it's generating more electricity. And if we turn the fan up to its 3rd speed setting, it generates even more. This, just like the other generators we've looked at, gives us one of the properties of generators that's an important feature. The faster you can get it to spin, changing or alternating that magnetic field through that coil of wire will generate a stronger electric current. Let's look at a different model windmill next. This windmill is built a little bit differently. Its top is free to rotate, and it has this large fin on the back. Windmills like this, and most windmills that are actually used for generating electricity, have some way to orient itself correctly in the wind to keep power generation going strong. So if I turn the fan on here, we'll see that the windmill orients itself into the wind to change with the changing wind conditions. Let's see how this windmill, in this orientation, generates electricity. In the direction that it's spinning now, the voltmeter goes into the positive range. Let's see what happens when we switch the blades around so that it spins now the other way. Now with the fan blades on in the opposite direction, we see that the electricity that's being generated is detected by the voltmeter in the opposite way. So the direction of current that flows through a series of wires on a DC motor will create direct current with a direction oriented based on how the magnetic field is being manipulated, how it's spinning. So the orientation of the magnetic field can be controlled by the direction of current in an electromagnet, or the direction of current can be controlled by the orientation of the magnetic fields and the way it spins in a generator.